This is Triangles, a massive building that houses an automated factory that has the capacity to manufacture 250,000 bicycles a year. Not too far away is Miranda, another nondescript building that manufactures cranksets for e-bikes all over Europe. This is Rodi, and as it turns out, a lot of this same machinery that produces sinks can also be used to make rims and wheels. Lots of them. Rodi, according to some industry websites, supplies 3 million rims and 400,000 wheels per year. All of these companies are within a half to an hour's drive from each other. And amazingly, this isn't in Asia, but it's in Portugal, in an area known as Bike Valley. So we traveled to Portugal to tour interesting bike shops and visit bike builders from small to established. But what we didn't realize was that Portugal was one of the largest manufacturers of bikes in the EU. But why? Why was there such a cluster of bike manufacturing and how did it all begin? Before we learn the modern story from the Bike Innovation Center, we took a detour to go back in time and visit Valdemiro. Valdemiro is the oldest working frame builder in Portugal. He was born in 1946 in the small town of Ovar. He joined the Cycling Federation to race in 1965 and was a contemporary of Eddie Merckx. There's still a picture from his racing days hanging in the showroom. After a few seasons, Valdemiro turned from racing to start a bike building business instead. We visited him at his showroom and workshop in Ovar, not too far from where he was born, just south of Porto. Over his almost 50-year career, he has built with steel, aluminum, and even carbon. He was completely self-taught, even teaching himself how to make molds and layer carbon fiber. And this was like long before YouTube. His machine shop looks like the stuff of dreams. At the height of his career, he was building bikes for Portugal's most elite cycling teams, producing up to 400 frames a month. In the 80s, with globalization, bike manufacturing started to move over to Asia, and things slowed down. These days, most of his work is in carbon repairs. There are stacks and stacks of boxes of carbon bikes to fix. But out of all the materials he has worked with, he still finds steel the best. What's his favorite bike that he's ever built?
São todas, são todas.
All of them. I got that. Son todos. This was an interesting peek into Portugal's bike building past, which now looks very different from its future. Hey there, everybody. Sorry for the interruption, but we were trying to get to the MADE show in Portland, and we need your help. It's an expensive trip, and because of that, we weren't originally planning on going. But we want to be there, film it, bring the content to you guys. So if you want to help us out, please consider joining us on Patreon or picking up some merch. It'll help pay for the flights and lodging and food and just make it so that we don't go into the red just to film MADE. Okay, back to the video. To see where it was heading, we went to the Bike Innovation Center, a government-funded project to give the businesses and factories in Portugal an advantage by giving them the tools to study and innovate in bicycle manufacturing, to shift from just supplying frames and parts to actually developing new technologies and techniques.
This area here has a long heritage in terms of bike production. It starts from bikes, motorbikes. 25 years ago, it changed to bicycles because the industry changes, the market changes a little bit also. So we are seeing a lot of production that came from Asia in terms of motorbikes. So the industry needs to adapt to new products. The know-how already exists because someone that can and know how to develop a motorbike, can also develop a bicycle.
So it's complicated.
Yeah. Here is the center of everything.
Yeah.
We like to call it this way. You are seeing that is a very large space.
Yeah.
Still a lot of empty spaces here, but all of the R&D will be done here.
Yeah.
So mainly the center has 4 areas of activity: materials, industrial processes and production technologies,
Yeah.
and product development. We have an area for prototyping. We prototype to study the process and to optimize the processes. We have conventional systems here, like CNC machining,
Yeah.
turning, welding, different types of welding. For instance, we have here the system that is the updated version of the system that is used in Triangles,
Okay.
the company that welds the frames in a totally automatic process. We have the updated version here, so you can weld MIG, TIG, MAG, and looking to the future to additive fabrication. that give us the possibility to print very large parts.
Oh, wow.
So with 300 millimeters plus 400 millimeters on height, so it's a large part. Two main advantages in terms of sustainability, because it uses less gas to produce, so we don't need to energize the chamber each time that we change the part. So it's very important for the industry, because we are validating technology that can be used, that should be used to the industry. So we are anticipating that. And the other point is you can sinterize directly 6061 alloy. That is the most important for the bike industry.
Right. So when you do all the testing on the processes, the idea is to do the research, share the resources, and then the companies, the brands you work with, like take it back to their factories, or they don't manufacture the stuff here. This is
No, we will not manufacture anything. We'll prototype, and we can validate the process.
So it's kind of like a creative sandbox.
Yes, yes. For instance, if I develop a new frame, I can develop the frame, modulate, simulate, and choose the material. Then I can weld it. I can even do the heat treatment process to validate the process. So in the end, I will give the complete set of instructions to industrialize the product. So we'll give the full solution, but the next step is in the industry. We have a very advanced system. You can enter here. Here we have a SEM microscope.
Oh, wow.
A very high-end one that is very useful to evaluate topography and morphology of samples.
Oh, wow.
We are seeing morphology of a sample. For instance, if I'm looking to a fracture area, we can identify the origin of that fracture. But in this system, we have also a super spectrometer. We can have a very high resolution in the terms of chemical determination. And we can also do study and determine very light elements like lithium. Normally, it's not possible in a system like this. In Portugal, we don't have anything similar to this. So it's very useful when we are thinking in batteries for the bikes. We can also use this to study the crystallography of the materials. This is what we are seeing here. Taking in consideration the boundaries of the grounds and the dimension and the orientation, we can confirm if the heat treatment, for instance, is what should be done or not. So to know if the mechanical properties of the product, of the material, will be aligned to what should be needed. In the end, it will give an idea about if it is okay or not, but not give us enough information to understand what is the problem. If I do some hardness measurements, I see a very low hardness in that point. Okay, this is not okay according to what we need. But the origin, only when we are looking to here, we can know.
So that's
So
like
that's more like a trial error.
that's like pass fail, but this tells you the reason why.
Yes, the reason why. That we also here is a tomographic system. So a CT scan system that you can use to, for instance, to understand the porosity of a sample, the delamination in the carbon fiber frame, or something like that. So it will be a large system, and it is interesting because we can have in the same system resolution and power. So I can have a very low resolution to see a fiber in a carbon fiber frame, to measure it, to understand the directions and so on. But I can also identify, for instance, some porosity in a mold. So for that, I need a very high power. So we will have two X-ray sources in the same system for that. Here's the material characterization area. So we have from metallographic microscopes, so hardness measurement systems, tensile test systems, portable, and more fixed with more resolution. To have some results, the industry needs to work with labs in Turkey or in Greece and so on. So in terms of REACH regulation and the WOS directive, we will be able to perform the full set of tests here. This is the area of the accredited tests. So from the wheel to the frame, to the pedal, to the cranks, we can test everything from fatigue, impact, or static tests. So we can do it all with temperature-free condition or during the test or before. The first areas that we have, because this knowledge came from Abimoto, the Portuguese association, that has this test area for more than 30 years ago. In the other pavilion, that will be a passage in the corner through three other systems that are very interesting for the bike industry. A vibration system to perform some vibration tests, an independent vibration in the front or in the back of the bike with temperature control. It's very important to study phenomena related with the electrical systems but also in terms of comfort of the rider. It's very interesting for that. It will be installed in the other pavilion. Other system that is very important, kicking in safety, is an area for crash tests.
Okay.
We will have an area that gives us the possibility to perform tests until 45 kilometers per hour.
Oh, okay.
So speed packs. We need also to have high-speed cameras, lighting, control, and so on. It will be installed on the other side. Last one, but not less important.
Yeah.
It will be a wind tunnel.
Oh.
A wind tunnel, real scale,
Yeah.
with all the needed features to be solution for our industry. With possibility to measure drag, the flow above the shape
Yeah.
of the products. We'll use it for bikes, for bike developments, but also to study, for instance, stability of cargo bikes.
Oh.
So the dimension of the tunnel will be large enough to do that.
Yeah.
But in a short time, we'll be fully operational in terms of R&D for bikes.
Right. So how does something like this get funded? Is it like a country initiative to be a leader in bicycling, or is it just through
Yeah.
membership of the?
The first point is to keep up the momentum of being the biggest bike exporter in Europe.
Okay.
After COVID, the government
Yeah.
creates some mobilizing agendas. One of the areas that should be supported is the bike industry because the results are clear for all. We, Abimota, the consortium, creates a mobilizing agenda called AM2R, Mobilizing Agenda for the Two-Wheel Industry, that puts together almost 50 entities from associations to companies to the academy to the municips, for instance, putting all together, creating a clear ecosystem to develop new products.
Right.
And to help the industry to change from the OEM conventional profile of work
Yeah.
to a ODM with some capacity to develop. In the middle of this ecosystem, it makes totally sense to have a center like this
Right.
to support the industry because part of the industry is able to do it alone, but the other need to have a center, to have the equipments and to have know-how to do it.
The people that work here, are they just independent technicians that you guys hire, or are they people from the brand when they do the testing?
In these moments,
Yeah.
because we are still capacitating everything,
Yeah.
are only our technicians.
Okay. Yeah.
But in the future, will be this share of knowledge with the technicians from the companies working here,
Right.
together with our technicians, or in some cases, alone, studying their own processes, their own products.
In our week in Portugal, we saw a bit of everything from new builders, builders that had moved from other countries to start over, builders testing out the idea of microfactories and small-scale automation, and finally, what could be the future of bike manufacturing in Europe. Despite all that, there was so much more to see, and we hope to return not only to see how bikes are built, but to actually ride bikes in Portugal.